Okay, in this tutorial, we're going to have a look at the statistical test known as standard deviation. And what I'm going to do is I'm going to talk in this tutorial about what is standard deviation, with what type of data sets would you use this test, and why do we use it? And I'll also go through a couple of examples in terms of how would you interpret a standard deviation result and what does it mean. In the second tutorial, you'll find out another key area of knowledge, which is looking at the suitability of this test and why we would use it, and maybe some of the weaknesses. Now, the first thing to acknowledge about the standard deviation test is, unlike tests like the Pearson test and the Spearman test and the chi-square test, which are statistical inferential tests, this is a descriptive test. It allows us to describe a data set. The simplest way of describing a data set is where you work out the average of the data set, or also known mathematically as the mean. And the mean is just one single number that is used to sum up the whole data set. So summing up a whole data set is where you add up all the values of that data set and then divide it by that number, which gives you the average. Now, standard deviation allows you to explore the data set and how spread out it is around that average. It does a very similar thing to what interquartile range does, in the sense that it will tell you whether the values are very clustered around the central value or very spread out. Now, the difference with interquartile range is standard deviation looks at the spread of a data set around the mean value or the average, whereas interquartile range looks at the distribution or spread of the data set around the central value known as the median, which is the middle value of a data set. So they're slightly different in terms of the way you would be describing the data set. Now, apart from standard deviation telling you whether a data set's very spread around the mean or not, it also has a predictive element, because one standard deviation represents 68% of the values lie within that, or depending on what those values are. Another way of thinking about it is, if you looked at average rainfall falling on a city in which you live for an entire year, and you did a standard deviation test on those total years for the whole 100, so the last 100 years of the total rainfall, you could get the average rainfall per year in the area you live. If you then calculate standard deviation, you would know that 68 of those 100 years, or 68% of those years, what the total amount of rain is likely to be, or the range in the total rain around the mean value. And we'll explore this idea of the predictive element to standard deviation later on in the tutorial. So let's look at a simple example. First of all, we have a bell curve, and the middle of that bell curve represents the actual mean itself. And what we're interested in is the number of values, the spread of those around the mean, what is known as one standard deviation. One standard deviation below the mean, or one standard deviation above the mean. 68% of our values of our data set will fall between this one standard deviation below and one standard deviation above. We can actually go a bit wider than that and look at two standard deviations below and above, and we could actually predict that 95% of our data set should fall within two standard deviations, and 99% of our, or 99.7 actually, should fall within three standard deviations. The only thing left to do is to actually calculate what the standard deviation value is, and then interpret what it actually means. Let's have a look at a really simple example. Let's say we've been into a shop and we have sampled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 men and 15 women. And when I say sampled, we have randomly selected 15 men and asked one simple question: what is your age? And the 15 men sampled, we can see here their ages. Likewise, the 15 randomly sampled women, we can see their 15 ages. Now, the first bit of analysis we can do is, what was the average age of the men? The mean was 41.7. What was the average age of the women? 51.6. Now, that doesn't tell us very much apart from the average age. It certainly doesn't tell us the spread of those ages. We can actually see with quick analysis that we happen to interview a number of older women, 2 women over 80, and in our male data set, we didn't have any older men. If we do standard deviation, we can calculate what percentage, in this case 68% chance, of bumping into men between what range of ages? Well, our standard deviation is 18.98. Now, if we just round that up to 19 years, what that really means is that 68% of the time we are going to randomly select a man that ranges between 19 years below this average and 19 years above this average. Now, just to simplify that, if we rounded this number up to 42, just to make it easier to understand, so the average man we were interviewing was 42, and we remember that one standard deviation is 19 over here, well, if we take 19 away from 42, we get to 23. So that would be the bottom end. That would be negative one standard deviation would be 23. Plus one standard deviation would be adding 19 to this number of 42. So add 19 to 42 and we get to 61. So the range of age of boys would be between 22 and 61. There would be a 68% probability chance that that would be the age range of people we'd bump into. We could do the same with women. In this case, our standard deviation is slightly a higher number, as well as our average being slightly higher, which means we have a 68% probability chance of bumping into women aged, if we just round this up to 24 years younger than this age, up to 24 years older than that age. Now, I've written that all out here below, you can see, and you might just pause to have a read through that. Now, what does this tell us? Well, it tells us that the men are more clustered around the average. The standard deviation is a smaller number. And the women are more spread out. There's, or what we might say, a greater degree of variance around the mean value because it's a larger number. That's the first thing we can do. Second thing we can do is we can also work out the probabilities of the range of ages we're going to randomly select. And I just described that a second ago, and you can read through that here. We could go a bit further and calculate the 95% probability, or indeed the 99.7% probability, which are 2 or 3 standard deviations, if we so choose. Let me just take this a little bit further and look at a more likely type of example that you might yourself do or encounter in an exam. Okay, in this exam question I'm going to show you, we have been given some river data for the River Niger in Africa. And we've been given the river discharge in cumex across the year for the 1967-68 year, going from May through to the following April. And we've also been given the 2013 to 2014 discharge levels of the River Niger. Now, the first thing we can actually do is we can work out the mean discharge for that year. And we can see that in 1967 to 68, the mean was 1,239 cumex. We can see that the mean in 2013 was lower at 838 cumex. What we're then able to do, if that is the mean, we get to see how these numbers vary around that mean. So a number that's lower than this number of 838 would be below the mean, and a number that's higher would be above the mean. So, for example, this very low level in April in 2013-14 was significantly below the mean for that year. Likewise, this QMEC level here in November was significantly above the mean. Now, that doesn't tell us too much at the moment, but we do have the average, and we can see that the average discharge was actually much greater in 1967 and 1968 than it was in 2013-2014. That's probably going to reflect different rainfall totals between those particular 2 years, because the discharge of river is most impacted by the actual rainfall. Of course, there could be changes in the landscape around and the way the land's being used, whether it's been deforested or not, which could also be influencing this variance in rain in cumex of the river. It's the same river, remember? It's just 50 years difference in terms of time. What's most interesting is the standard deviation. So this, remember, is one standard deviation around the mean. So what would be the likely rainfall that we would experience across that year? 68% of the time, the rainfall should range between minus 773, that's minus 773 off this number, or plus 773 above this number. So just roughly speaking, we're talking about a variance between 500 QMEX and 2000 QMEX. And if we actually look through this, most of these values do fall between 500 and 2000. We can see 1, 2, 3, 4, 5, 6, 7, 8 of the values fall between that range, with 4 of them not. Remember, 68% of the time, or 68% probability, that the rainfall is going to vary between that. There's a 95% probability it will range between 2 standard deviations, which would be 2,700 and 0. Remember, we can't go below 0 QMEX. So if we have a little look, well, actually, all of our values go between that range. Okay. What we also can see, apart from the probability, is that the discharge in 2013-2014 was a much smaller number than it was the standard deviation in 1967-1968. So there was much greater variance around the mean in 1967-1968 than there was in 2013-2014. Another way of putting that is that the discharge of the river was much closer to the mean. The average month had numbers much similar to the mean in 2013-2014 than it did in 1967-68. And here you can see the typical kind of question, which in this case asks you to analyze the data. And there's a big mark tariff there. So analyzing the data would involve you talking about the differences in the range of the two rivers between the 2 years, comparing the wettest months of the 2 years, the driest months of the 2 years, comparing the different means and the different standard deviation results and what that actually means as well. Follow-up question is also the suitability of using standard deviation to investigate, which I would suggest you watch the second tutorial to find out why we would indeed use standard deviation.